Hello everyone, this is Ari from pantechelearning. Okay, so is my voice is clear? Is my display is visible, guys? Anyone in the chat box? We will get into the session. Okay. Yes, I think it's clear. Okay, guys. In previous session, we saw how to create we have developed the code for I2C. Today we are going to configure the I2C. Okay, the screen is not visible clearly. So Ramesh, is the screen is now it is visible? Is it is clear? Anita, good evening. Namita, good evening. Shreya, also good evening, guys. Good evening, all. So, guys, is my screen is clear now. We will get into the topics. Okay, guys. Okay, we will get into the today's session. Okay. So, in the previous session, we have saw how to create we have developed the code for I2C. Okay. So, today we are going to implement those codes. Okay. So, we have already created this system I2C configuration settings, and we have created the initialization settings. And I have already teach you how to derive those formulas and to how to give the values for T raise and CR. Okay. So then we have created the start condition and address and to write the function and to stop the condition. So what is the module we are going to interfere? So we are going to use the module I2C module is BCF 8574T. So this is the module which we are going to interface with the STM32 controller. Okay. So you can see here we have a dedicated 7 pins of outputs from P0, P1, P2, and these 4 pins are reserved, and the P4, P5, P6, P7. So we can, by giving I2C communication with this, initializing I2C communication with this module, we can give data to this 7 pins, okay, from 0 to 7 pins, okay. So today we are going to interface this module with the STM32 microcontroller. So you can randomly see this module with the LCD. So the nowadays for Arduino I2C LCD, in Arduino we will have an I2C library for LCD. So all the LCDs will be interfered with this module only. So what is the use of this module? Well, there is a difference between I2C LCD and normal LCD. So what is normal LCD means? We have to connect the 0 to 20 pins to the LCD, and we have to give the instructions in bitwise. We have to send logic 1 as per the requirement, as per the what is the thing you have to display. When you use this module between the communication of LCD between the STM controller and LCD means you can use these 4 pins to send the data to the LCD. So that is the advantage of this module. So by using this module, we can use the LCD by using the 2 pins, which is SDA and SCL, which comes under the I2C communication. Okay. So guys, this is the addresses. Okay. So as I explained in the previous session, so I2C we can connect the multiple slaves and multiple masters, right? So consider we will connect the one master and we are going to connect the three I2C module. Same this module, we are going to connect these modules, three modules. Okay. So you can see we have an addresses for this module. What is the address? So as I teach in the previous class, that the I2C is going to communicate with, not it is going to select the or send or request the data by using the say select pin. It is going to select it by, wait a second, the voice is slow. So it is going to be select the slave by sending the addresses, right? So we have to know what is the address for this specific module I2C IC. So you can see we have a A0, A1, A2. So as per this, we will have an addresses. So if you want to write means you have to use these addresses. If you want to read means you have to use these addresses. So what is this is the A0, A1, A2 will be defaultly in the I state, which is DDD means it is I. When it is VSS means it is ground. It is logic 0, it is logic 1. So it will be in the default state of, it will be in the A1, A0, A1, A2 will be in the I state, which is it will be in the logic 1. So I will use this 4E address to communicate with the I2C module 1. Then I have to again I communicate with the I2C module 2, which is the same module. How will I communicate with it? So it will have a same addresses, right? So for that purpose only the A0, A1, A2 is used. So for first module I will use this first default address, which is 4E, and for second module I will ground the A0 alone. If I ground the A0 means then I will send the address. The address will be 4C. So when I sending the address, it will check with the address. So for third module, third I2C module, I will ground this A1 alone. So now we have getting the 4 address for 4 modules, but the 3 different addresses for 3 modules, but the 3 modules also same. Okay. So I can send this. If I want to write the value in the third module means I will use this 4A address, because the third module's A1 is grounded. So if I want to use the second module means I will use the address as 4C. Then if I want to communicate with the first module means I will use the address 4. So this is the reason for using the addresses. Okay. So today we are going to configure this. So we will get into the KEIL ID first. Okay. So as we see, SDLSF we have developed the code for system clock, initializing the I2C. Then we have created the start condition, and stop condition, and the address function. Then write function. Okay. So today we are going to send the addresses. Okay. So first what we have to do, we have to initialize the system clock. Then we have to initialize the I2C. Then inside the while, I'm going to run it repeatedly. Then I'm going to send the addresses one by one. So I'm connecting only one module right now. So my default A0, A1, A2 value is I. So what is the address will be? The address is 4A, as I shown in before. Okay. So it will be address is 4A. So the first I2C will start the condition, then it will send the address 4A. Then when the address is matched, the next microcontroller will be get ready to send or read the values from the slaves. Okay. Okay. Then I'm going to write the value to it. So as I shown, wait, I will show it in the. So as I shown you before, we can send data to the 8 bits. So from 0 to 7. So how we will send it? If you send off logic 1 to the 0th pin means it is going to be set as logic 1. Likewise, we are going to left shift the logic 1 to these 8 bits. Okay. For that purpose only, I have created the for loop from 0 to 8. Okay. So it is going to send the value from the first bit, and it will left shift it by second bit, and the LED is going to be, I'm going to wait a second. So I'm going to connect the LED with these P7, P6, P5, P4, and P2 and P1 and P0. So I'm going to send the logic 1 to these bits line by line. Okay. So for that purpose only, I initializes the for loop, and I'm adding the addresses. As per the loop, the I will be, first it is set as a 0, then it will stop the condition and it will give a delay, then it will again go to the for, then the I will be condition will be get added, then it will come as an I1. Okay, so this is a process what is we are going to do. Is the my voice now it is clear? Still voice is low. Okay, fine. Now is it is clear? My voice is clear, guys. It is. Is it is louder? Okay. So we are going to blink the LED one by one. Okay, in a sequential manner. Okay. So next we will connect the board to it. Then I will compile it. So we have a 0 errors. Okay. So then before this, what we have to do? We have to go to the debugger, select the ST link. What is the debugger you are using? Then go to the ST link. Under reset, it is under reset, and you have to go 8 megahertz and reset and run. Okay. So we will upload this code. So now we have uploaded this code. So now I will show you the output, guys. Okay. Wait a second, guys. So you can see the I2C model LED is blinking in a sequential way as per the bitwise changing. It is sending the logic 1 to the P0, P1, P2, P3, P4 and till the P7. So this is how we will configure the slaves with the masters. Okay. Now we will change the condition. Okay. So wait a second. Now we will change the condition. So wait. I will take this for. Okay. Then we can simply give the address directly. So I'm going to tune on the LED one. Okay. So this is going to tune on my LED one alone. Wait, I will show you. So guys, you can see that LED one is tuned on. Okay. So if you want to tune on the LED 2 means you can give 0 cross of X. So LED 2 is tuned on. So likewise we can tune on the specific LEDs. So this is how the I2C module is communicating with LCD panels also. So it is going to tune on the values. So now what has happened? It is we are given as 3. So sum of the first bit and second bit is value is 3. So if I want to tune on the third LED means I have to give it as a 4, 0 cross of 4. So this will tune on my third LED. So guys, you can wait, I will show it. So you can see the third LED is tuned on. Likewise, we can configure the all the LEDs. Okay. Okay. So this is how we will connect the I2C module with the controller. Likewise, we can connect interface whatever modules we need, which is comes under the I2C communication protocol. Okay. So guys, next we will get into the next topic. Okay, is this topic is clear, guys? So if you have any doubts, means you can ask in chat box. I will give a time for it. Okay, you can clear the doubts now itself. If you have any doubts, means I will give a time for chat box right now. Okay. So the projects will be available for the live students also and for internship students also. When it comes with internship, it is going to be in a detailed and expanded manner, and some projects are going to be added. Okay, that is what the difference between the live and the internship. Okay, guys, and you can interact with me directly, and you can ask the questions, and you can clear your doubts for while you're developing a project. If you have any doubts, means you can clear it with me directly with me one to one. Okay, so that is the benefits of the internship. So Balakrishnan, it is not possible with the protease, guys, because we can't simulate the STM32 controller with the protease. But I think STM32 F01 series is available, but we are using this F407, so it is not available in the protease, guys. Is this I2C concept is clear, guys? Can we go to the next topic? So I'm using this New Vision 5, which is the latest version. Okay, Kishore, yes, the topic is clear. Okay. So guys, I'm using is Mu Vision 5 IDE, which is latest version, which is available in Google. Okay. Okay, guys. So we will get into the SPI communication. What is SPI? It is a serial peripheral interface. Okay. So like I2C, it is also can be connected multiple slaves, but we can use only one master. So SPI is in a single single master and multiple slave concept. When you compare with I2C, I2C is a multiple master and multiple slave concept. Okay. Okay. So Sasikala, I will after finishing this SPI communication, I will explain it. So for this reason only, guys, I'm saying you to enroll for the internship, guys. So when it comes with internship, you can make use of it and ask the questions and clear the doubts as per the required time. Okay. Okay, Pooja, I will send it the project link, and I will send the one good project for you in the WhatsApp group, guys. Okay, I will by tomorrow I will send the project. Okay, no problems. Okay. Okay, guys. First, we will see the SPI communication. We will see the introduction to SPI communication, and I will come to the I2C code again. Okay. So, guys. So before that, you can now convert this masterclass into an internship. So it is a 1 month internship on embedded systems. So guys, this is the internship which will be very much useful for you guys. So you can interact with me directly, and every day Saturday class will be one-to-one session. So guys, the codes, what are the doubts you are related to the codings and related to the code development, you can ask me directly, guys. So it will be in a very detailed and explanation manner. So guys, use this internship. The fees is 1200. So the discount is for 509. Use the CSMC1 coupon code to get the fees of 691 rupees. Okay. So guys, avail this offer, and you can use this internship to gain more knowledge, and it will be very much useful in while developing your projects or developing a code. When you have some errors, means you can interact with me directly. Okay. So no issues, guys. So what are the benefits we are going to see? So we will have a 30 days of live session. It will be recorded videos. The recorded videos will be available for 30 days. This live recorded video will be available. Then for 90 days access will be provided for you. And as asked in the chat box, guys, the hands-on practice on embedded projects will be available. And the projects will be very much expanded in a detailed manner. And we are going to add lots of projects in the internship compared to live. And we will have 6 mentor live classes. So one mentor live classes is over in today's Saturday class. So guys, within next Saturday you register it and you can ask directly doubts to me one-to-one session in next Saturday class. Okay guys, so make use of it. So after registering you will get an internship confirmation letter and you will be provided with an internship certification. So we will provide 2 certifications. One is for participation and one is for course completion. Okay. So guys, in this internship you will get an 30 days of videos, PPTs, project codes, plus confirmation letters, plus 90 days access and 2 e-certificates. So it is all in one internship. So make use of it guys. Okay. So how to register it? So registration fee is 1200 and after the Zoom class completed means it will be sold for the same rate. So use this coupon within now. So use this opportunity. So use this coupon code as ESMC1. It is not I, it is 1. So the discounted price is 509 and the fees will be 691 only. Okay guys. So use this link. The link will be provided in the chat box guys. So join the batch 2 today onwards and get the offer of the batch 2. Okay, the batch 1 registration has been over. So from today the batch 2 registration is getting on. So guys, use this registration link to get an offer and register using this link. Okay. So next class you can ask me questions directly. So guys, next. So now we will enter the concept. Okay. So SPI communication. So it will use as a not like I2C or UART. UART and I2C will use the 2-wire communication, right? When it comes with SPI, it will use the 4-wire communication. So one is MOSI, which is a master out and slave input, and another one is master input and slave output, and it is a synchronous communication. Synchronous means it will communicate, it will send and it will request and send data with the clock pulse. So that is what synchronous communication is. And we will have a slave select pin. So what is this slave select? It is a new concept, right? When you compare with I2C, so when you take a UART means we can't connect multiple masters and multiple slaves. When you take I2C, we can connect multiple masters and multiple slaves. So how does the master decides which slave should receive or from which slave I have to get the data? So it will use as the address, right? When you compare with SPI communication, it will use as a slave select pin. So if I want to for scenario, if I connected 3 slaves, okay. So I will connect the 3 pins, slave select pins with those three slaves. If I want to communicate with the first slave means I will give the input to the slave select pin, then the data will be sent or requested from the slave 1. If I want to get the data or send the data to the slave 2 means I have to select the slave select 2 pin. So likewise, so we will see the on upcoming slides. So we have a 4 pins which is MOSI and MISO, and we have an SCL clock and we have a slave select pin. Okay, and it is a serial communication. When it comes with I2C, it is a maximum speed is 5 Mbps per second. When you come with SPI, its maximum speed is up to 10 Mbps per second. Okay, then it will have some 4 wires and it is a serial communication. Okay, so we will. So this is how it will communicate. So we are going to see the parallel difference between the parallel and serial communication. So when it comes with parallel, it is going to send the data in the parallel way. So for example, if I want to send the letter C means it is going to send this bits in a bit form, binary form. So it's going to send these all the bits in the parallel way. So you can see it in the image, right? So it is going to send it at the same time. This is how it is going to transfer the data. When it comes with serial communication means like UART, like I2C, it is going to send the data in 1 by 1. So if I want to send the character C means the data will be sent in 1 by 1 format like this image figure. Okay. So guys, you can see. So this is a single master with multiple slave, and this is also single master with multiple slave, but we are using a 1 slave select pin for configuring 3 slaves, but here we are using 3 slave select pins. So as I explained in the previous slide, that if I want to communicate with this slave 1 means I will enable this slave select 1 pin and the clock source will be going to the slave and we can send or request the data from this slave. If I want to communicate with the slave 3 means the slave select pin 3 is tuned on. Then I can communicate with the slave 3. So if consider I didn't have enough pins, so I don't have enough that much pins, then I can use this communication protocol. So I can connect the 3 slaves also with the same pin. So then I can select the which slave I can use by using the single pin itself. So we will expand it in coming slides. Okay. Okay. So is it clear, Ashwati? So this is how the communication. So you can see that we have a 3 slave select pins here, and we can also use the 1 slave select pin to configure the 3 slaves. Okay. In case of we didn't have sufficient pins. Okay. If we have sufficient pins, we can use the 3 pins for connecting the 3 slaves. Okay. Okay. Next, we will see how the SPI data transmission works. First, the master will sense the clock signal. Okay. As per it is a synchronous communication, so the first thing the master will do is it will send the clock signal. Okay. Then the master switches the SS pin to low voltage. First, the clock pulses are sent. Then the master will switch the SS pin to the low voltage, to the logic 0 from the high to low to activate slave. This will activates the slave. Then the master will send the data 1 bit at a time because it is a serial communication, right? So it is going to send the 1 bit at a time in a serial communication. Okay. Then the slave responds and slave returns the data in 1 bit form. Again, the slave will sense the data, what is the data it received, and what is the response it has to give to the master. It will sense against to the master through the MISO pin, which is a master input and slave output. So this will send and the master will reach the bit. Okay. So what are the advantages and disadvantages? When like UART, when you see the UART and I2C, we will have a start bit, stop bit, all the things. When you see the SPI, we will not have a start bit or stop bit. There is no interruption, not complicated like addressing. So when you see I2C, we have to see the addresses, right? We have to use the addresses for communication. But when it comes to the SPI, it is simple like switching the pins, like switching the LEDs. That's all. So data can send and receive at the same time because we are using 2 pins for sending and receiving the data. We can also use it by configure the 1 pin as a bidirectional. We can send and receive the data in same pin also. We have options. Okay. So what are the disadvantages? So disadvantages, it uses 4 wires. When you compare to I2C and UART, it uses only 2 wires. There is no acknowledgement bit. So in I2C, we will have an acknowledgement bit. The data has been transferred. We will get an acknowledgement bit. But when in SPI, we didn't have that. And we can connect only one master. That is the problem. So that's why they have developed the I2C communication. Okay. So now we will get into the registers. So before that, I will explain the I2C code. Okay. So guys, is it visible for you? I will explain it. So guys, first you have to initialize the system clock. Okay. So we have enabled the power interface clock. Then we have tuned on the HSC, which is a main crystal. Then we have checking whether the HSC is tuned or not. Then we are tuning on the PLL and we are giving the PLL source. We are selecting the HSC as a PLL source. Then we are setting the M and N value for 60 to generate the system clock at 64 megahertz. Then I am checking whether the PLL is locked or not. Then I'm using the PLL as a system clock in configuration register, and I'm giving the AHB bus values, which is div by 4. Then I'm checking whether the PLL is used as a system clock. Okay. So next is init I2C. When come with init I2C, first you have to enable the clock for I2C. Then you have to enable the clock for GPIO. Why? Because we are using the pin is PB8 and PB9, which is in the port B. So we are enabling it. and we are selecting alternate function for both the pins P8 and PB, P8 and P9. Then we are selecting the model register as an alternate function for these two pins. Then we are setting the frequency. We are saying what is the frequency we are using, what is the pre-clock frequency. Our pre-clock frequency is 16 megahertz, and our CRR value is 80, which have been I already shown you how to derive it in the slide. And we are giving the value to the CRR as 80. Then I am giving a maximum frequency rise time, which is 17 megahertz, which is 16 megahertz. We have to give maximum, so plus 1, it is 17 megahertz. Then I am enabling the I2C. Okay, this is the init function. Then simply we have to start the condition which is available in the 8th bit in control register, and we have to check whether the condition is started or not, or it have to wait till this condition is bit is get settled. Okay, then we have to send the address. We will send the address, and we will wait for the address to, if the address matches, it will be the SR1 register will get logic 1 here. Then we have to wait till this happened, and we will read this to clear the ADDR. Okay, register. Then we will we have created a write function. This will simply write the data to my data register, I2C data register, and I have to wait till the data register get empty. So this SR1 7th bit is going to say, it is going to set when the data are transferred from the register to shift register. Okay, we have to wait till this get happen. Then we have to simply stop the condition. Okay, so this is a software milliseconds delay. So in mean we have to give the first, we have to initialize the system clock, which we have already defined in the upper. Then we have to init the clock. Then we have to first, inside the while, we have to first start the condition. Then we have to send the address. What is the our module's address? So our module address is 4E. So we have to send the address, and we have to write the data. Then finally we have to stop condition. If you need means to see the we are connected LED, so we have to see the LED blinking. So I have given the 25 milliseconds of delay. So this is how the code is developed. Okay. So guys, is it understand? So this is how the I2C is created. Okay. Okay. So now we will get into the SPI registers. Okay. Okay. We will see what is the specific things we are going to configure for developing a code. Okay. So first is control register. In control register, we will have a clock phase and clock polarity. So I will explain it what is clock phase and clock polarity later. Okay. So we have to set these bits according to the what is the function we need. I will explain it in a detailed way. Okay. So then we have to select as what is the thing we are going to do with this controller. We are going to use this controller as a master or slave. So I'm going to use it as a master. So I will give a logic 1 to this second bit. Okay. So next is baud rate. So we have to say what is the frequency we are going to use. So my frequency is 16 megahertz. So I will use this state, which is 16 minus divided by 2. It is 8 megahertz. So our baud rate will be 8 megahertz. Okay. So we have a 6th bit as an SPI enabled, and we can say the which bit is first transmitted, LSB or MSB. Most significant bit or least significant bit. Okay. Then these two bits are used for NSS pin, which is a slave select pin. I'm going to use the same as NSS pin, or I'm going to use the software pins. As I shown you in the slide, I'm going to use the same pin, or I'm going to use the 3 pins for selecting the slave. So you can see I'm going to use the specific slave select pin means I will left it as an a 0. If I'm going to use the multiple GPIO pins to select the slave means I will give it as an a 1. So this is the function of the bit. Okay. Then we have an RX only bit. So by setting 0 logic 0 to this bit, we will configure it as in full duplex, so we can transmit and receive. Okay. Then we have a DFF, which is a data frame format. We can send the data in 8-bit and 16-bit also. We have to say which is how many bit we are transferring the data. So I'm going to use this 8-bit of transferring data. Okay. Then we will come to CRC calculations later. Okay. So these are in the. So when you come with more, we will use in a 2-line unidirectional. So one pin is used to communicate, send the data, and one pin is used to receive the data. Okay. If you use this bidirectional means you have to set this. Okay. So I'm going to use the unidirection. So no need of setting this 4th bit. Okay. Then we have a control register 2. We can in this register we can enable the interrupts for TXNE and RXNE like UART. And we have a frame format. We have 2 modes for SPI modes. We have a TA mode and Motorola mode. We are going to use this Motorola mode. Okay. Then if you are using the same NSS pin means you have to give logic 0 here. If you are going to use other pins, GPIO pins for selecting the pin means you have to set logic 1 in this pin. Okay. Then it is DMA. We are not going to use data memory access interrupts. We are not going to into those concepts. We will come into the later. Okay. Then we have a status register. So we have a busy flag status register. So this is going to say when the data is transferring, it is transferring or not. Okay, if it is transferred and the data is transferred means it is going to say it is going to logic 0. So we have to wait till this bit is get settled. Okay. Then we have a TXE and RXE as like UART and I2C. So we are going to wait till this bit is get set to send or receive data. Okay. Then we have an SPI data register, which is from 0 to 15. Okay. Then so these are the things we have to see according to the registers. Okay. Okay. Okay, guys. We have seen what are the registers in this. In next session we will see what is clock polarity, what is clock phase, and how to we will develop the code for SPI communication. Okay, guys. Okay. Last, we will give one time for a chat box, guys. If you have any doubts and queries, means you can ask in chat box. Okay. 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 I will upload this codes in the WhatsApp group, guys. No issues. Okay. Okay, guys, use this internship and register for the internship to get a one-to-one session and to get more knowledge. So, guys, use this offer to upskill yourself, guys. Okay. So tomorrow we are going to develop the code for SPI communication and we will interface the two controllers, okay, two microcontrollers to communicate with each other, okay. So guys, attendance link has been provided for the day 6. So you can use this link for attendance form. Okay, thank you guys. Thank you. So Sudha, I think you didn't understand the code correctly. So Sudha, try to register for the internship and you can specifically ask what is the specifically on which part is you can't understand in the internship. So guys, use those internship to ask me questions. Okay. So Sudha, use those opportunity to ask me to clear your doubts. So you can specifically point on the code to what is the at what place you need help means you can ask me right there. I will from coming slides I will try to explain it more detail in the live. When you come to internship, it will be very much detailed. So no issues. Okay. So Srija, thank you guys, thank you for the session. Okay, guys, we will end this session. We will meet in next tomorrow session. Okay.